Okay, hi, Mr. Hanna here. In this video, we're going to be looking at inverses. It's an extremely important concept, and you've probably been using them in some way without even realizing it. Now, when we're talking about the inverses of functions, we can only do it for one-to-one functions. So you remember that a one-to-one function is a function like a linear function, for example, where for every x value, there's only one y value. For functions that aren't one-to-one functions, you need to restrict them by getting rid of some of them before you can find its inverse. So just noting that, and I'll come back to that point later on. Now, what actually is an inverse? Well, an inverse is basically it's kind of like an opposite operation. So, for example, we say that that plus and minus are inverses of each other, or times and divide are inverses of each other. In other words, inverses are the things that undo. Things that undo. Undo. Inverses are things that undo. So, for example, if you had, 2 plus 1, and then you found out whatever the answer to that is, and then you did x minus 1, you get back to the first thing you had of 2. Okay, so it's sort of like the opposite. It's like undoing something. Or another way to explain it when we're talking about an inverse function, and let me, maybe at this point I'll just say an inverse function you write as f negative 1 of x. Okay, it's the inverse function, and that's how we write it. So let's just consider a function machine like we've done before. So a function machine is one in which you put in your variable x, and in the machine it does the function of x, and you get out some output which is the function of x. Now suppose you've now got another function machine, and this one's the inverse function. Okay, so you've got the inverse function here. So you're going to put your output from the first function machine, f of x, into this one. So in there what's happening is you're actually putting, instead of your input x, it's going to be f of x. So you're doing your inverse function of the first function you did. Then what's going to happen is out, you just get x. Okay, so you put x in. If you put x in and do a function to it, you get out the function of x. Then if you put the function of x into the inverse, so like this, you put the function of x into the inverse, you get out x. Okay, so let's do another example. So you know that that squaring something, the opposite to that is the square root of the same something. So if I said that f of x equals x squared, then you know that the inverse function is going to be the square root of x. So here's sort of an example. Let's suppose that x is equal to 2. Then you can say that the f of x is equal to 4 because it's 2 squared. Now if you wanted to do the inverse function of the function of x, that's like doing the inverse function of, well, the function of x is 4, is the function of 2. So maybe I'll write it like this, is the function of 2, and that equals the inverse function of 4. And the inverse function is the square root, so the square root of 4 is, of course, 2, which is our x. Okay, so it's kind of like this cycle. The inverse is the thing that sort of undoes it. So whatever the inverse is, it's the thing that undoes your function. Okay, so a common question might be, how do I find the inverse? Find the inverse function. Okay, how do I find the inverse function? Now let's do this with a very, very easy example, the example we've just done. So suppose we have y equals x squared. Okay, the way to find the inverse is first put x in for y, and put y in for x. So we'll change it to x equals y squared. Now what we're going to do is solve for y. Solve for y. Okay, so we're trying to get y by itself. So to get y by itself, we're going to do the square root to both sides. So if we do the square root to x, we get the square root of x. And if we do the square root of y squared, we just get y. So here we say y is x squared. So in this case, we now have the inverse function of x is the square root of x. Okay, so let's try another perhaps more slightly more complicated looking example. For this next example, I'm going to use the index law, the one that says if you've got a number and it's got some sort of index and you take that all to another index, the way to find the answer is that's your number and with the two indices multiplied together. So for example, let's just do a quick one. 2 to the power 3, if you then do it to the power 4, that is 2 to the power 12 overall. Okay, so now to this inverse function. So suppose we have y equals x to the power 3. Then we're going to swap our x and y, so it's going to be x equals y to the power 3. Now we're going to solve for y. So what we're going to do is we need to get y back just to a y. So to get y cubed just to y, we're going to do it's y cubed and we'll do it to the power of a third. Because then it's y equals 3 times a third, 3 times a third, which equals y to the power 1, which is just y. So we've got y on one side, and on the other side we've got x to the power of a third. And that's perfectly fine if you want to leave it like that. It's perfectly done. Otherwise, you know that x to the power of a third is the same as a cube root of x. So our inverse for this time, our inverse function, is the cube root of x. Alright, let's try one last example of an inverse. So let's start with y equals 2 square root of x divided by 5 minus 10. Okay, so first we're going to swap the place of y and x. So we'll have x equals 2 root y divided by 5 minus 10. Now we've got to solve for y, so we're trying to get y by itself. So first I'll add 10 to both sides. X plus 10 equals 2 root y on 5. Now multiply it by 5, so we'll have 5 x plus 10 equals 2 root y. Now divide by 2, so it's now 5x plus 10 divided by 2 equals the square root of y. And now I'm going to square both sides, so it'll give me y on this side, so I'll swap the order. Y equals, and squaring it all, so 5x plus 10 on 2, and everything is squared. Now if I want to, I can neaten that up a little bit and have squared, so that's 5 squared is 25, x plus 10 squared, and over 2 squared is 4. So there we go. Or I can finish up by writing the inverse function is therefore equal to 25 times x plus 10 squared over 4. And I'm done. I have written algebraically the inverse function. So if I put a value of x into this one, if I put x into that one, and then whatever my answer is, so if I write answer, and then if I put this answer into here, to do f negative 1 of the answer, I will get out my initial x value. And that's how inverse functions work. Okay, next up we're going to see how we can actually sketch inverse functions or inverse relations as well in a bit of a a shortcutted way other than just finding the equation. There's another way we can sketch these inverse functions. So let's have a look at that. Wow. Okay, so sketching inverse functions. So the key thing we've sort of learnt is, so far with inverse functions, so for inverses, y becomes the input, and x becomes output. X becomes the output. Okay, so let's consider if we just had a relation, so just a couple of points. We'll do the inverse, we'll plot the inverse of just a couple of points. So let's suppose we had the points 1, 1, and 2, 4, and 3, 9. Let's suppose, and let's do one more, why not? And 4, 16. Okay, so I'm going to just plot those points and then do the inverse as well. So first off, we're just doing the function that gave us these points. So let's just plot these points as they normally would be. 1. Okay, so 1 gives, let's do this scale, has to go to. Okay, so 1 gives 1, that's here somewhere. 2 gives 4. 3 gives 9. 9. And 4 gives 16, way up here. Okay, so there are our 4 points. Now, if y becomes the input and x becomes the output, all that's happening is our x and y's are swapping. X and y's are going to be swapping. So we can just list those points again and do a new graph if we want to. So this first point becomes 1, 1, so no change. Second point becomes 4, 2. Third point becomes 9, 3. And third point becomes 16, 4. So whereas this graph sort of did this sort of thing, if we plot our, badly done, our new points, so let's, maybe I'll just do it over here where there's lots of space. Alright, so here we'll have 1, 2, 3, 4, and 15. Okay, so this first point, 1, 1, is about here. Second point, 4, 2, so 4, 2. Third point, 9, 3, 9, 3, and third point, 16, 4, 16, 4. So this one has more of that sort of look. So where this one kind of comes up, this one goes across. So what's really happened here is if we draw a bit of a line right through the middle, so this dashed line is y equals x, so it's got a gradient of 1, we've sort of reflected our initial points along the graph y equals x. So if we reflect it along that, it will change to that sort of a shape, being reflected along this line. So hopefully you can see that as it's a bit of a shortcut. Okay, so here's one more example. So here we've got this graph, which is y equals 2 to the power x. So if we want to find the inverse, we can do a dashed line right through here. So that dashed line in the equation is y equals x. And we can reflect that along that line. So imagine folding your page across that line, and that's what we would have. And so what it ends up looking like, another way to think about it is when x is very small and negative, y is small and positive. So that'll change because when x is small and negative, y will be small and negative. And when y is small but positive, x will be small and positive. So that is here is sort of a starting point. This is the point that corresponds to out here. And then you can think of other points where across the y-axis, so across the y-axis, small and positive, if you like. So across the x-axis, small and positive here. And then up here, they're both small and large. So you can think about it that way. And that is what our inverse looks like. So this here will be our inverse function, this line here, using that fold. Now, as I said at the very start of the video, you can only find the inverse if the function is a one-to-one function. So, for example, if you had, if your function that you were asked to find the inverse is y equals x squared, which, as you know, looks like this, first you need to restrict it so it's one-to-one. So maybe we'll change the domain to be only this positive bit. So here I've changed the domain to be 0 to infinity. So if you change the domain, now you can find the inverse. So you can either find the inverse by doing a bit of a line and then sketching how it would be reflected, which would look like this. Like that is the reflected bit, that bit that I've just done there, which I'll go over to make it a bit more obvious. There we go, so that's the inverse there. Or you can do it algebraically. Now, because I've restricted that, I know that only the positive answers are going to be, or only x is only positive, which means I can easily do the square root. So if I swap my x and y values, and now I solve for y, then I get y equals the square root of x, and that is the graph that I've already drawn. So there we go, that is inverse functions.